All right. Find the expected frequency for the given value of n and p. So the frequency for the goodness of fit, it's the percent times the total. And he gives you the percent to be 0.3 and the total to be 120. So if you guys want to find the frequency, you just take 0.3 and times it by 120. This is one of them. And that will give you what? 36. And that will be the answer. That's it. Done. So next question. Let me clear here. Now, this is a complete problem. So this is section 10.1, guys. We're reviewing goodness of fit. So please pay attention to this. A research firm claims that the distribution of the days of the week that people are most likely to order food for delivery is different from the distributions shown in the pie chart. Here's the pie chart right here. You randomly select 487 people and record which day of the week each is most likely to order food for delivery. The table to the right shows the results. What you see in the table are observed values, and what you get off the chart is the expected values. Test the researcher's firm claim at alpha equals 10%. Okay. This is what I told you about HO and HA. HO will be the distribution is as claimed, and HA will be distribution is not as claimed or has changed. So let's pick up the answer based on what I just said. So it's as shown in the pie chart. Here you go. And let's see if our students can tell me what is it going to be. What is it going to be, guys, for HA? That should be easy. Actually, there's one choice that works here.
Differs.
Differs from the expected distribution, exactly. Which hypothesis is the claim? He says, look, guys, they claim that the distribution is different from expected. So you should agree with me, it's HA. If they say it is the same as expected, will be HO. If it is different, HA. Calculate the test statistic. Okay. We did this by hand, but I'm not going to have you do it by hand on the test. You could, but there is no need. These are the observed values. We need to put them in L1, and we need the expected values, and we're going to put them in L2. So let me bring the calculator up, guys. Clear the screen, stat, edit, put the L1 observed values in L1 to begin with. That's the first thing that you have to do. So 40. I'm gonna go slow with this question because it does reflect on all the questions on this section. 47, 43. And please, guys, later go back and do the work. It's good to listen to me. It might make sense, but just probably a few hours later, you would forget. Even if I watched a movie last night, you ask me if I remember the details, I'll tell you I have to think about it. So can't retain everything in the memory. So that's why we need to practice and take notes to retain this knowledge. Okay, L2 are the expected values. And here's how I taught you to find the expected values. You take each percent, guys, and multiply it by the total. And the total in this question is 487. So here's how you do it. Watch. 0.08 times 487. No need to round here because you're not doing the work by hand, so that's fine. 5% for Sunday. For Monday, I'm sorry. So 0.05 times 487. 7%, 0.07.
Professor, don't you have to divide it by the number of categories or no?
Oh, no, this is only for uniform. No.
Okay.
You divide by number of categories if the question was, is the distribution uniform? And he doesn't give you any percentages. If he doesn't give you any percentages, guys, he's telling you that all the percentages are the same. So for expected value, you count the categories and divide, but not in this case. Look, you have different percentages. So you have to treat them differently. Let's see where we are. Okay. For fourth one, Wednesday is what? 13%, 0.13 times 487. For Thursday, 10%, 0.10 times 487. And for Friday, 0.36 times 487. And finally, for Sunday, 0.2921 times 487. And now, guys, stat, tests, scroll up. I know some students don't have it on their calculator if they have an older calculator. That's why I told those students to download this app that I'm using right now or use Statcrunch. I'll show you how to use Statcrunch in this one. Enter. Observed values are L1, expected values are L2, degrees of freedom of number of categories -1. So 1, 2, 3, 4, 5, 6, 7 -1 is 6. That's by accident here is 6. So it's not, calculator doesn't know. You have to put it there and hit calculate. And chi-square, guys, is round to 3 decimal places will be 49.037. And the p-value, here's why I want to pause here, because there was a major mistake on the chapter 9 assignments. I know some students work together because they make the same mistake. The p-value is not 7.328, guys, or 329. The p-value can't be bigger than 1. And many of you put on chapter 9 assignment, the p-value was 2.1. How could the p-probability be more than 100%? Impossible. That means the students did not look at the E there. When you see the E -9, that means your p-value is 0. You have to move the decimal point 9 digits to the left. So this p-value, guys, is 0.000000007. So you just put 0.0000. That's it. Don't ignore the E right here again. Don't ignore this. You ignore it, you lose all the credit on this question, because that's very, very important right there. So we go here, we put the p-value, which is 0.00, 3 decimal places, so just 3 zeros, and reject HO, of course. And at the 10% level, there is enough evidence to conclude the distribution of the days people order food for delivery is different from the expected distribution. That should give you full credit if you do that. How would you do this using Statcrunch? Watch, open in Statcrunch. These are the O's. You still need to put the E's in Statcrunch, which you already done on the calculator. So I'm just gonna go to the calculator and I have to copy them. So 38.96. So you have to do the work, guys. 24.35. 34.09. If I'm not mistaken. 63.31. For Thursday is 48.7. For Friday, Saturday, 175.32. Oh, that's Friday. And for Saturday, 102.27. Okay, watch, guys. You go to stat. Where does it say goodness of fit? Look right here. You can't go wrong. It's goodness of fit. Chi-square test. Observed values are frequency. It's a frequency. These are the observed values. Expected values are variable 3. This is where I put them. And if you want to display the expected, compute, and here you go, guys. 49.037, that's exactly p-value. Now, what does this mean? It means 0. Just put 0, it's going to work. When he put the p-value is so small, less than 0.001, means it's very small. And look, all those expected value. So reject HO and support the claim. Okay. So let's clear drawing and go to the next question. Okay. I know a student asked me about dividing by the number of categories. It's going to work here. A researcher claims that the number of homicide crimes by season is uniformly distributed. If I give you the word uniformly distributed, means all categories are the same. We are making a claim that they should be the same. So if I have like 40 students and I have 100 points, each student should be getting exactly the same points. So you just take 100 divided by 4, it will be 25, 25, 25, 25. That's what uniform means. To test this claim, you randomly select 1,193 homicides from a recent year and record the season when each happened. The table shows the results at alpha equals 5%. Test the claim. So the claim uniformly distributed. So they're the same. They did not, it's okay. Is uniform. And the HO is always not 2. So is not uniformly distributed. That's HO and that's HA. Which hypothesis is the claim? It's HO, because he says they claim they are uniformly distributed. Okay, how do you do the test statistics? We can do, let me do it in Statcrunch first, and then I'll do it on the calculator. Okay, we know the total, guys, is 1,193. So right here, you're gonna take 1,193 and divide it by 4. And I got 298.25. 298.25. 298.25. Each one is 25%. 298.25 and 298.25. And go to stat. Goodness of fit, chi-square. Compute. So chi-square, guys, is 1.920, and the p-value is 0.5891, which is bigger than alpha. So chi-square, you just put, he says 3 decimal places, you put 1.920, and the p-value 3 decimal places, you put 0.589, which is failed to reject HO. There is not enough evidence at the 5% level of significance to reject the claim that the distribution of the number of homicide crimes by season is uniformly distributed. How do you do that? By using the calculator, guys. Watch. Okay, let me just clear the lists. Clear, enter. I like to clear the screen so you don't get confused here. So just put the observed. First of all, the observed, 304, 314. These are the frequencies, the results of the survey, 293 and 282. And here, guys, what was it? 298.25. I mean, you could do 25% of each. It's going to be 298.25 for everybody. So that's what uniform means. If you have 5 categories, you divide the total by 5. 6 categories, you divide by 6, and so on and so forth. So I should match with Statcrunch, guys. If I don't match with Statcrunch, we're in trouble. All right, stat, tests. Scroll up. L1, L2. Okay, degrees of freedom. Who can tell me what are the degrees of freedom? Don't leave it at 6. You'll get the wrong answer here. What are the degrees of freedom here? Yes? You can put it in the chat.
It's the number of categories minus 1.
Which is?
3.
Yep. It is 3.
Professor Bezi, I'm kind of confused how you got L2.
Oh, L2, look. Let me just go back to it. Okay. He's asking you to test the claim that the distribution of crimes is uniform among seasons. It means uniform means that the crimes are the same. They have the same number of crimes in spring, summer, fall, or winter. So this is what you do, Ape, here. You just take the 1,193, and how many categories do you have here? You have 1, 2, 3, 4, just divided by 4. And the expected values will be exactly the same. If you divide 1193 by 4, you get 298.25. You just put 298.25 everywhere. Okay?
Okay, thank you.
So that's how you do it. And then you go stat. So this is the word uniform. That's the hint for the word uniform, if you see the word uniform. And then you go to goodness of fit test. L1, L2, degrees of freedom. Degrees of freedom, guys, for goodness of fit test is number of categories minus 1. Here's how I count them. Spring is 1, summer is 2, fall is 3, winter is 4, 4 minus 1 is 3. And hit calculate. Okay. So you get 1.920 for the chi. You see, it's exactly the same as Statcrunch. P-value is 0.589, which is more than alpha. Failed to reject the null hypothesis. There is not enough evidence to reject the claim that the distribution is uniform. All right. Next. Okay. The pie chart shows a distribution of the opinions of parents on whether a college education is worth the expense. An economist claims that the distribution of the opinions of teenagers is different from the distribution of parents. So different from. To test this claim, you randomly select 202 teenagers and ask each whether a college education is worth the expenses. The table at the right shows the results, test the economist claim, and here's the chart. Very similar to the distribution of food for delivery, guys. Exactly the same problem. So the distribution of the opinion on whether a college education is worth the expense is the same as for teenagers. And then here it's not going to be not the same. There you go. That's it. You don't have any other choices to choose here. Where is the claim? The economists claim that the distribution is different. So different, the word different takes you right away to HA, guys. And calculate the test statistic. We can do that on the calculator. Let me just bring the TI-84. I think I lost the calculator. Let me put it back. It's nice that TI gives us 90 days to try this calculator out, guys. So that's really nice. Okay, so we go stat, edit. My observed values are what's given in the table for me. So I'm going to put those first. We're still in section 10.1, guys. So 86, 62, 36, 14, and 4. Okay. Now we're gonna go to L2, clear it. Okay. If you ever, guys, delete L2 by mistake and you wanna get it back, here's how you can get it back. You go to stat, and then you go to number 5. Enter, oops, sorry. And we go back to stat, number 5. Well, that's clear. Stat, number 5. Enter, enter. It will give you back everything that you deleted. So edit. Now for L2, guys, you agree with me, these are gonna be the percents of the total. It's not uniform, he gave me percents now, so they're different. And what was the total? He says 202 teenagers. Okay, so here, guys, the first one, it will be 0.55 times 202. And then strongly agree, 30%, so you do 0.3 times 202. And next one, 5%, 0.05 times 202. Next one is 6%, 0.06 times 202. And last one, 4%, 0.04 times 202. If you add L1, guys, the entries in L1, you get 202. If you get the entries in L2, you get 202 as well. So you go to stat now, tests, scroll up, goodness of fit test. Observed L1, L2, number of categories. Well, I have how many? 1, 2, 3, 4, 5. 5 minus 1 is 4. And hit calculate, guys, and that's it. And we bring the calculator back. Chi-square is 74. How many decimals? 3,472. P-value. Oh, you see, E minus 15. Don't ignore that, please. Don't put 2.58, guys. That would be a big mistake. So it's 0 here. Reject HO. There is enough evidence to conclude that the distribution of the opinions of whether a college education is worth the expense is different for teenagers and parents. That's how you conclude the question. Yeah.
Okay.
So these are the conditions of the one-way analysis of variance test. The samples must be independent of each other. The samples must be randomly selected from a normal population. Each population must have the same variance, and there must be at least 3 samples. This is for section 10.4. These are the conditions, guys. Take a note of that. And I will send you scan the handout as well and send it to you guys for chapter 10. Probably I haven't done that yet. Okay, now what we're doing, a question in section 10.4, analysis of variance. The table available below shows the weights in pounds for a sample of vacuum cleaners. The weights are classified according to vacuum cleaners at alpha equals 1%. Can you conclude at least one mean vacuum cleaner is different from the others? Look, guys, there's the hint I gave you. If you have a table that has more than 2 samples, you know it's ANOVA, analysis of variance, the last section in the book. So he wants us to check, can you conclude at least one mean vacuum cleaner is different from the others? So this is how I taught you to do this. HO, guys, will be always mu1 equals mu2 equals mu3. And then HA will always be this statement. Don't change it in any question in chapter 10. At least one of the means is different from the others. Now let's select one. Now you go here, guys, you notice that you don't see 1, 2, 3, but he used the abbreviation, just of the headings. So mu1 equals mu2 equals mu3. At least one of the means is different. It's right there. Now, how do you do this on the calculator? You have to input the data into your calculator. So let me just clear here. You go to stat, edit, and I need the list. So let me just get the list. And that shouldn't be very much of a task, guys, for data entries. You can see it's not much work to do data entries here. In the book, you see them in vertical format. The samples, it just put them in row format, it just to make the space here. So, but it's the same thing here. So 22, 19, 24, 22, 25, 21. Actually, after this section, guys, we only have one section to review. As I told you, 10.3 is not included in the test. So L2, 21, 24, 18, 18, 20. The three samples don't have to have the same size, but it happened that they have the same size here, which is fine. (26), 27, and 21. Okay, I'm done here. So, can you conclude that at least one mean vacuum cleaner weight is different from the other? So the claim is in HA. And here's how you get the test statistics. So you go to stat tests, scroll up, guys. It's the last test. ANOVA. Put L1, second and number 1, comma. Second and number 2, comma. Second and number 3, close, enter. And F is 4.51. You can see a match, guys. The p-value is 0.029. And what's alpha here? Let me see. At 0.01. So this is bigger than 0.01. So fail to reject the null hypothesis. Do not reject HO. There is not enough evidence to conclude that the mean weight vary across the vacuum, or at least one mean is different from the others. That's this one. How do you do it, guys, using the Statcrunch? Watch. Open in Statcrunch. Go to Stat, ANOVA, one way. We're not doing two way. Select the columns. Here's how you select the column. Press and hold the control button on your keyboard, and you select them like that. And that's it, I think. Compute. And here's where F is right here, guys. Let me just highlight. There you go. That's a test statistic, and that's the p-value. The p-value is bigger than 0.01. Fail to reject HO. There is not enough evidence to support the claim. Any questions? I think the next question is going to be something also similar to this one. So let me, oops, sorry. Share screen. All right, next question. The table of below shows the cost per miles in cents for a sample of automobiles at alpha equal 1%. Can you conclude at least one mean cost per mile is different from the other? It's exactly the same as the previous one, guys. Look, what you have 1, 2, 3, 4, 5 lists. Okay, so what would be HO and HA? HO will be mu1 equals mu2 equals mu3 equals mu4 equals mu5. Where do I see that? And then HA will be at least one of the means is different. The only option I can see right here, it's C. Find the test statistic. Let me do it in Statcrunch, guys. If you do it in calculator, put this in L1, L2, L3, L4, and run ANOVA. But look, in Statcrunch, watch. Very easy. I will have Statcrunch available when you take the test, so you can use it if you wish. ANOVA, one way. Okay, we need to select them. So press and hold the control button on your keyboard. And here you go, select them. Compute. And here's F. And the p-value. So F, guys, will be 2 point, how many decimals? 2.77. And the p-value, if I just go back and show you the p-value, it is 0.0544. And what's alpha? 0.01. So bigger than alpha. That's bigger than alpha. Fail to reject HO. There is not enough evidence to conclude that the mean cost per mile is vary across the automobile. Any questions, guys? That shouldn't be hard, you know, just, oh, there's another one. You see too many questions there. There should be a hint for you whether there's going to be a question from this section or not. There's quite a bit of those. All right. The data found below measure the amount of greenhouse gas emissions from 3 types of vehicles. The measurements are in tons per year expressed as carbon dioxide equivalents. Use a 0.025 significance level to test the claim that the different type of vehicle have the same mean amount of greenhouse gas emissions. Same means, that means that claim is in HO. Based on the results, does the type of vehicle appear to affect the amount of greenhouse gas emissions? Well, let's see what we have here. Okay, guys, you can do this on the calculator. Let me just do it on the calculator this time. So I'll pause the recording until. Okay, so you go to stat. So let's select the null and the alternative hypotheses. It will be, as we said, mu1 equals mu2 equals mu3. At least one of the means is different from the others. And he says, test the claim that the different types of vehicles have the same mean amount. So the claim is in HO. Okay, so now you go to stat, tests, scroll up, guys. Oops, sorry. Scroll up, ANOVA, put second and number 1, comma, second and number 2, comma, second and number 3, close, enter, and F is 124.936. Wow. And then the p-value is 0, guys, 0.000. Let me just look at my data. That's strange value. Just make sure that we didn't mess up anywhere. Well, yeah, it looks okay. Yeah, if I miss the decimal point, that will ruin the whole thing. So just tests, scroll up, ANOVA, and you get the results, guys, there. And if you want me just to show you, complete it. Yeah, we were correct, very large. See, it changed the values once I put, and the p-value is 0, reject HO, and there is, we can conclude that the type does appear to affect the amount of greenhouse, because yeah, they're not the same, then the type of vehicle makes a difference, because we rejected HO that they are all the same. Okay, next question. The table below, this is again section 10.1. list the number of games played in a year best of 7 baseball champion series, along with the expected proportion for the number of games played with teams of equal abilities. Use a 0.05 significance level to test the claim that the actual number of games fit the distribution indicated by the expected proportions. Here, guys, he didn't give you the proportion as a percent. He gave them to you as fractions, which is very much the same. These are the frequencies, 18, 19, 21, 38, and these are the expected frequencies. So HO and HA. Let's select them. I got this from a different book, so it's going to be slightly the wording different, but it's very much observe, agree with the three of the expected. Right here. And the second one will be do not agree. They're different. Okay, how do you do the the test statistic? Is a goodness of fit test, guys. So if I wanna, you could do Statcrunch, but if you do Statcrunch, you still have to provide the expected values. So I'm just gonna do the calculator here. So we're gonna go to Stat, Edit, L1, guys. I'm gonna clear it. I'm gonna clear L2. And let's put the observed values 18. And I want the students to tell me how I'm going to calculate the expected values. 19, 21. What's the total here? 38. If you add them up, what do you get, guys? 18 plus 19, 37. And 21 is what? 58. 88, 96. So who can tell me how to find the expected values here? Let me just clear L3 so you don't doesn't confuse you. You didn't give me percents here. So how would you figure out 2 out of 16 of the total? What would you do?
You would multiply it?
Yeah, it's the same thing. Or you can change 2 over 16 to a percent. If you change 2 over 16 to a decimal, guys, it's 0.125. So you can do 0.125 times 98. Enter. 4 over 16 will be 0.25. I will give you, mainly I'm gonna give you percentages so you don't get confused, but to just show you that it could be a decimal proportion, guys, so that's fine. 5 over 16, guys, just divide 5 by 16. I got 0.3125. Just take 0.3125 times 98. And finally, 5 over 16, same thing. 3125 times 98. Okay, go to Stat, Tests, scroll up, Goodness of Fit test. We're coming. Chi-square test will be the last thing, guys, we do today. Degrees of freedom, I got 1, 2, 3, 4 categories. So my 4 minus 1 is 3. And calculate. And here you go. Okay, our claim is in HO because he says that's the claim that the actual number of games fit the distribution. If he say they're different than expected, there will be HA. So chi-square is 8.735 if you look at my calculator screen. P-value, guys, will be 0.0330. And what's alpha here? 5%. So less than 5% reject HO. So you have a choice between B and C. Let's read them and select the proper one. We say the claim is in HO. So there is enough sufficient evidence to warrant rejection of the claim. Yeah, then that's B. Next. Now, guys, it's section 10.2 independence test. Here's a hint, guys. This is how you can tell if you have a test of independence. You see this table is called contingency table. It has headings in the rows and headings in the columns. This is what we call a contingency table. In this case, we have an independence test. And he's going to ask you to check whether the variables are independent or dependent. So you see, this is another hint for you. The table below includes the results from polygraph lie detector experiments conducted by researchers. In each case, it was known if the subject lied or did not lie. So the table indicates when the polygraph test was correct. Use a 5% significance level to test the claim that whether a subject lies is independent of the polygraph test indication. So people can lie, and the polygraph, whether it indicates they did or not, they can still lie without, just a polygraph, detecting this. That's what we're trying to check here. Do the results suggest that polygraph are effective in distinguishing between truth and lies? Okay. Remember, in this section, guys, I said HO should be the variables are independent, and HA should be the variables are not independent, means dependent or related. So from this spirit, follow my wording and try to find out the null and the alternative hypothesis. Okay. Not C and D, guys. They don't make sense. It's about dependent and independent. So whether a subject license is independent of the polygraph test indication, exactly, that's what I said. And it's not independent, means dependent. That's the one. Okay. And we want to see if they are independent. So the claim is in HO, guys. So just keep in mind that the claim is in HO. Just one sec. Okay, let me just bring the question back. There you go. So because he says it's independent, so the claim is HO. Just keep that in mind. Okay, here's how I taught you guys to do this using the calculator. You need to put the data into a matrix. And here's how you do it. Look, you go to second and matrix X inverse right here. You go to edit and you press enter, and you decide how many rows of data and how many columns of data. We have 2 rows of data and we have 2 columns of data. So it's a 2 by 2, guys. Enter. And just enter them. That's it. 11, 42, 12, and 7. Oops, what did I messed up. So I'm going to go back. So we got 11, enter, 42, enter, 12, enter, and then 7, enter. Okay. And we're ready to run the test, guys. You go to stat, tests. The last test that we haven't used today yet, it's chi-square test. So the independence test, guys, is chi-square test. That's the test that we will be using. Let me just write it down here. For section 10.2, that's the test. All right, chi-square test. Enter. Observe values in A. It's going to put the expected values in B automatically, and you just hit calculate. And here you go, guys. Chi-square. Let me bring the calculator back. Chi-square is 11 point, how many decimals? 3, 5, 6, 7. P-value, guys, is 0. Look, don't ignore the E. It's 0.0007. So 4 decimal places will be 0.0007. All right. And what's alpha? Alpha is 5%, so that's less than alpha. Reject HO. There is enough evidence to reject the claim. So there is sufficient evidence to warrant rejection of the claim right here. How would you do this using Statcrunch? Let me see if we can do this using Statcrunch. Open in Statcrunch. Let's see if it's going to open properly. Oh yeah, it did. Good. So look, you go to Stat. Where's the chi-square test? Oh, graph, just one sec. Tables. So pay attention to how to do the chi-square test using Statcrunch. Tables, contingency with summary. Okay, select the columns. The columns, I have 2 of them. Did not lie and lied. Row labels. Okay, that's the one, and that's optional. That's all I need. Just hit compute, guys. And here you go. You get the p-value, and look, 0.007, exactly what we did, and that's the test statistic. Okay, so you could use the Statcrunch as well. I'm gonna bring the calculator back. Let's say he asks you, he wants to see the expected values. The calculator already put him in matrix B. So here's how you find them. You just go to second, X inverse B, and then select B and press enter twice. And enter again. And these are the expected values. 16.9, 36.07, so on and so forth, 4 of them. Okay. And the way how we did the expected values by hand, if you remember, guys, we did the total here and we did the grand total. And to find the expected value of 11, you have to take the total of the row that 11 belongs to times the total of the column that 11 belongs to and divide by the grand total. But you don't need to do that. Calculator can do all of this for you. All right. And let's go. We're almost done. Results from a civil servant exams are shown in the table to the right. Is there sufficient evidence to support the claim that the results from the test are discriminatory? Use a 0.0 significance level, meaning that whether you pass or fail is related to whether you are a white or a minority candidate. So that means there is a relationship between the two. Okay, determine the null and the alternative hypotheses. We need independent and dependent. So there will be this one here. There will be H white and minority have the same chance, and white and minority don't have the same chance. And we need to check whether they don't have the same chance, because that's what discriminatory means here. Okay, how do you do the test statistic, guys? Let me just do it on the calculator quickly. So I'm gonna clear this. You need the matrix first. Look, this is how you get to the matrix. This is algebra. Second, inverse, math, edit, 2 by 2. It is a 2 by 2 actually here, guys, so it's not. And now let's do the entries. 17, 19, 10, and 26. That's it. And go to stat, tests, scroll up, and it's chi-square test, guys. And you don't do anything here at all. Just hit calculate. Oops, I picked the wrong test. Stat. You know, I went to B. Now we're good. And now just hit. Let me do a draw for you here. There you go. It's a right scoot test always. Chi-square is a right scoot test, guys. So p-value will be shaded to the right always. It looks small. So the test statistic is 2.9037 and the p-value is 0.0884. What alpha are we using here? 0.01. So it's bigger than alpha. Failed to reject HO. So p-value is 0.0884. There is not sufficient. So the claim is in, we said the claim don't have the same chance. So there is not enough evidence to support the claim that white candidate there's not sufficient evidence to support the claim that the results are discriminatory. It's right here, guys. Okay. Any questions? Next. Let me see. Many people believe that criminals who plead guilty tend to get lighter sentences than those who are convicted in trials. The accompanying table summarized randomly selected sample data of defendants in burglary cases. All of the subjects had prior prison sentences. Use a 0.0 significance level to test the claim the sentence sent to prison or not sent to prison is independent of the plea. Okay. Same thing, guys. So pleading guilty, let's see. The sentence is independent of the plea. You can see it's part D. Remember what I said. HO is independence, H1 is dependence, and that's the only language is right here. So that's the, and it says independence, so you know the claim is in HO, guys. And again, to get the test statistic, you have to go to a matrix. It's been 2 by 2 here, which is nice. And then we go to edit. Enter. So it's even faster, as fast as using Statcrunch here, 403. As long as you remember how to input the matrix. If you don't remember how to put the matrix, then there would be a problem here. 59. And then go to stat, chi-square test. Enter. And you see, you're going to get the observed values. And so test the statistic 1.186, guys, you put it right here. P-value is 0.2761. Which is more than alpha. Failed to reject the null hypothesis. There is not enough evidence to reject the claim. Right here. All right, next. Almost done. In soccer, serious fouls result in a penalty kick with one kicker and one defending goalkeeper. The accompanying table summarized results from 297 kicks during games among top teams. In the table, jump direction indicates which way the goalkeeper jumped, where the kick direction is from a perspective of the goalkeeper. Use a 1% level to test the claim that the direction of the kick is independent of the direction of the goalkeeper jump. So do always go to in the same direction. That's interesting questions. Do the results support the theory that because the kicks are so fast, goalkeepers have no time to react? So the direction of their jumps are independent of the directions of the kicks. Yeah, I think the goalkeepers, because it's so fast, they just jump in any direction and hoping that it will be the direction where the ball will be coming, you know. So jump direction independent. Okay, right here, it's B. Do you guys agree it is B here? So independent, so the claim is in HO. I think you guys agree. Claim, because it says it's independent. Okay, let's see the table. I can do that using the calculator again. So watch, guys. So second in matrix, this shouldn't take much time. Edit, enter. It's a 3 by 3 here, you guys. You have 3 rows of data and 3 columns of data. So 3 by 3. I know 52, 4, 45. Never done had detailed review of a test like we're doing today because time allowed us. So that should be, I'm hoping that will be helpful. 44, 5, and 58. By the way, guys, the degrees of freedom for the chi-square test is number of rows -1 times number of columns -1. You have 3 rows, -1 will be 2, and 3 columns, -1 will be 2. 2 times 2 is 4. But you don't need it in the case of the p-value. Just run the test. Stat tests, chi-square test. Okay, calculate. So chi-square, guys, is 11.078. P-value is 0.02569, and at what alpha he wants us to check at the 0.01. So remember, so this is bigger than alpha, fail to reject the null hypothesis. And if you fail to reject the null hypothesis, you say there is not enough evidence to warrant rejection of the claim. He helped you here and put to reject the claim. So all you need just to choose there is insufficient evidence to reject the claim. If you have a question to find the expected values, guys, here's how you find get the expected values. You go to second matrix and you go to B because they're in B. Enter and enter. And here they are. All of them. Scroll to the right, you can see all of them. With so many decimals. If you change the mode here to 2 decimal places, you will see only 2 decimal places there. Okay, last question. Okay, well, this, as I said, it will not be included on the test, but I'm just gonna do it for the sake of the homework, guys. And that should be it. This is section 10.3. Listed below are time intervals between eruption of a geyser. The recent times are within the past few years, and the past times are from 1995. Does it appear that the variation of the times between eruption has changed? Has it changed, guys, means it could be positive or could be negative, so it means not equal to. Remember, change means not equal to. So if you want to choose the correct null and alternative hypothesis, it will be B, because the equality is in the HO and this is HA. This is a 2-sample F test, and let me get the table, guys. Oh, let's do that. Clear. So we need to enter the data in L1 and L2. Just a couple more minutes, guys, we'll be done. Please bear with me. 75, 95, 87. I mean, I could prepare those data sets beforehand, put it in the calculator, but the problem is you cannot put everything on the calculator. There is a limit of how many lists you can pre-prepare. 87, 69, 91, 78, 83. Now let's go to L2. And 86. He didn't give me a summary. That's why I'm putting the data there, but I'm going to show you that you can still work with that. No problem. 94, 99, 65. Usually he'll give you S1 and S2 and N1 and N2. He didn't. 65, 86, 84, 92, 84, and 98, 88, 91. Okay, we go to stat, tests, and then, okay, tests. It's a two sample F test when you compare variances for section 10.3. It's E. Okay, guys, data, not the stats. You see, when it is stats, just like we did in 10.3, you put S1, N1, and S2, N2, but now I have data. So enter. L1, L2, don't change the frequency. We're testing that sigma 1 is different from sigma 2. That's all I need, and calculate. Let me bring the calculator back. So F, guys, the test statistic is 2.09 or 0, it's 2.1. And the p-value is 0.2345 or 234. So 2.1 and 0.234, which is bigger than alpha. Alpha is what here? 5%. Fail to reject a null hypothesis. And where is the claim? The claim is in H1 because it says changed. So there is not enough evidence to support the claim. Let's see if it is between C and D. Yeah. The variation of time between, variation of the times between insufficient evidence. You see, this is the catch, guys. He put some. I usually say there is not enough evidence, but it's the same thing as insufficient. And there is enough evidence means sufficient. So I'm going to conclude, guys, my, so there will be C here, but I'm going to conclude here, not enough evidence means insufficient. And enough evidence means sufficient. Just keep that in mind. And that's it.